And welcome to 12.1, where we're going to be talking about the arithmetic of equations. In this chapter of Chapter 12, which is entitled Stoichiometry, we're going to be talking about how you can predict how much reactant is going to produce how much product. Or you can take a look at, if you have a certain amount of reactant, how much of another reactant are you going to need? Or if you want to make a certain amount of product, how much byproduct is going to form with that? Okay, that's all a topic called stoichiometry. And so let's consider how we put together a tricycle in this first example. In this case, if you look at this being your final product right here, how do you get to that final product? Well, you need one frame. This is a frame right here. You need one seat. You actually need three wheels, one set of handlebars, and two pedals to make your tricycle. And so if you notice, you have your one frame, your one seat, your three wheels, your one handlebar, and your two pedals in our hypothetical formula here for our tricycle. And so what you can do is you can use the ratios of each of these components to determine how much of each piece you need to make a certain amount of tricycles. Here's what we mean. If we wanted to make 50 tricycles, how many of each part would we need? Well, in this case, we're going to start out with 50 tricycles, and I'm going to use the abbreviation FSW3HP2. You want to make 50 of those. So therefore, how many frames are you going to need over here? Well, you need one frame for every one FSW3HP2, and so that's going to give us 50 frames that you're going to need. If you do the same type of calculation, you're going to need 50 seats to make 50 tricycles. Now with the wheels, you need 3 times the number of wheels as you're going to be making trikes. So that means that you're going to need 150 wheels to make your 50 tricycles. For handlebars, you're going to need one set of handlebars, so you'll need 50 of those. In pedals, you need 2 pedals for every trike, so you're going to need a total of 100 pedals. Alright, so using these ratios, you can determine how many of each part will go into making your product. Well, as it turns out, it's going to be the exact same thing when we're dealing with chemicals. And so we call that whole process that we actually just did there stoichiometry. Kind of a funny word, but all that simply means is that you're going to be measuring quantities and then changing them over to a different substance. All right. So let's take a look at what the balanced equation tells us, and then we'll get into doing some calculations. First of all, this is the production of ammonia. You have nitrogen gas with hydrogen gas to produce ammonia, NH3. And when we first learned how to balance equations, you went through and balanced based on the number of atoms of each element. So we have 2 atoms of of nitrogen on this side. We have 2 atoms of nitrogen on this side as well, 1 on each ammonia. You have 3 times 2 gives you 6 hydrogen atoms, or you got 1, 2, 3, 4, 5, 6 hydrogen atoms. And 2 times 3 gives us 6 hydrogen atoms on this side. So we have 6 hydrogens and 2 nitrogens on both sides of the equation. So that equation is balanced. And so that's one thing that the balanced equation tells us, is how many atoms of each type of element that you have. Now what it also tells you is that one molecule, that's molecule, one molecule of nitrogen, which is N2, reacts with 3 molecules of hydrogen, which is H2, and that's going to form 2 molecules of ammonia. All right. Now you can do this reaction 12 times. So if you multiply this thing by 12, you would just have 1 times 12 molecules. You would have 3 times 12 molecules of this, and you would have 2 times 12 molecules of that. You can easily do this reaction 12 times. Now, if you did that, you could kind of slightly talk about this in a different way. You can say 1 dozen molecules of N2 react with 3 dozen, I'll abbreviate it, molecules of H2 will produce 2 dozen molecules of ammonia. That is also valid. Or, instead of multiplying by 12 and using dozens, we could do this reaction 6.022 times 10 to the 23rd times. And so in this case, you would have to multiply that one by 3. And this one by 2. Oops. Okay, so so now what we've done is we've done this reaction 6.022 times 10 to the 23rd times. Well, rather than writing out the number, just like we switched 12s over to dozens, we can switch these over to moles. So we can say 1 mole of nitrogen will react with 3 moles of hydrogen to produce 2 moles of ammonia. And this typically is how we're going to be referring to the equation. We're going to be referring to them in the number of moles of each reactant producing numbers of moles of each product. As we move on to the next section, section 12.2, we're going to start to show you how you can do actual calculations where you're going to be changing from one element to another. We'll see you next time.